All right, let's get this show on the road. Hey, everyone. And by the way, sorry if I clear my throat a lot. Throat's been dry, air travel. What can I tell you? Um, hi, my name is Jeremy Wagner, and I am currently a technical writer for Google on Core Web Vitals. Thanks for coming to my talk, which is a little foray into what it takes to get a streaming service worker working, and all the performance and UX benefits that can bring. I will say that this talk does assume that you know about the Service Worker API or Workbox, an open source tool that abstracts it, which is the primary tool that is used in this talk. If you don't worry. You'll get the gist of the concepts I'll present, but like later on, if you want to like experiment with it, you may have to like kind of toy with it, the API or Workbox on your own a little bit later to get like the basics and then get up to speed. But if you like Service Worker, I think you're going to like this talk. And it's also not like a totally unique concept. This concept has been presented on before, but like I'm very interested in promoting it because I think it could be a really good alternative to the single page application architecture while preserving the existing browser's default navigation scheme. So first things first, this is the first time I've left Minnesota since the pandemic began. And for those of you who are native to Europe or Portugal, Minnesota is in the upper Midwest in the United States, and it gets really cold. Watch the movie Fargo sometime. And I got to tell you, I'm definitely a little nervous / rusty on this side of things, but I'm super excited to be traveling once again and seeing new parts of the world. I have not been to Portugal. I really miss traveling, and Porto is just like an incredible city. It is a city of staircases, and I've been getting so much exercise. And I've been eating a lot of paella and walking more than I have in a good long while. So thank you for all your hospitality and willingness to sit through this talk. And paella, I love paella. I'm hoping y'all get something out of it. All right, so let's get into it. Before we get into the streaming aspect of service workers, we need a very quick primer on the service worker technology itself. According to the 2020 HTTP Archive Web Almanac, only about 3.22% of mobile websites observed deploy a service worker. And this technology has been around for a long time, so it's kind of like, really? Like, it's been around that long? Like, it just hasn't quite gotten in there. So this is also like, hey, I want you to use service workers because when they work right, they really add a lot. So given that statistic, it would be unreasonable to assume that everybody has experience with this technology. Without a service worker, web browsers will request assets from web servers, stuff like HTML, CSS, JavaScript, and what have you. And those servers respond with data to those requests. In theory, it's not terribly complex, though it can be in practice, but that's the gist of it. Service workers add a new wrinkle to this dynamic. A service worker is a JavaScript file that runs off the main thread. It has its own dedicated thread, which means that everything that it does doesn't impact responsiveness on the main thread. On the first visit to a website, a service worker is registered, installed, and activated. Once activated, it controls pages within its scope. And that scope is often for an entire origin. And on that origin's behalf, it can intercept requests, cache responses to requests in a special service worker cache that is distinct from the disk cache or the HTTP cache, modify responses to suit application needs, allow for push notifications and background sync, allow offline access, which is really awesome, and improve performance by responding instantly to requests from the cache, faster than even the disk cache can do at times. And as is the focus of this talk, use streams and streaming to instantly respond with partial markup from a service worker cache to significantly improve navigation performance. So that last point brings us to this thought. On the web, there tends to be two navigation patterns, at least that I've observed. The synchronous navigation scheme that browsers provide by default. We all know what this is. You request an HTML document, the browser downloads the markup, parses it, constructs the DOM, and then when that page is navigated away from, it is unloaded and disposed of for a new document. Rinse and repeat until the user is done. Websites that use this navigation scheme are sometimes called multi-page applications or MPAs. I just tend to call them websites. But then there's the single page application or SPA scheme, which is a navigation scheme that uses JavaScript, and it's often provided by userland solutions. Think like a Preact router or Reach router or any number of those things that are like that we've been doing for quite a while. SPAs only use the default synchronous navigation scheme for the initial request to get the application shell. Then each navigation request is a sequence of requesting data from an API or HTML provided by some endpoint on a server, and then populating the content area in the application shell with a lot of client rendering in JavaScript. And this brings us to an alternative, which, if I'm being truthful, is really just a clever extension of the browser's default navigation scheme involving streams. Yet streams and streaming isn't a new concept. When browsers download HTML, they incrementally parse HTML in chunks. And this is so the browser's preload scanner can get a head start on discovering render-critical resources such as CSS and other potentially important resources such as images and scripts. This is especially important for extremely large HTML payloads where performance would suffer immensely if the browser was blocked by the network until the entire payload arrives. Where are you going with this, Jeremy? That might be the question you're muttering to yourselves, because if the browser already streams HTML from the network, then what difference does it make if we introduce streaming logic into our service worker? The answer is, it's because Service Worker gives us a very powerful performance optimization, the cache storage API, which we can use in combinations with the Streams API, specifically the readable stream interface. But we already have caching in the browser. Isn't that what the Service Worker cache uses? Yes and no. And to understand why, we must look to the onion for an answer. Browser caches are complex, layered mechanisms that can interact with one another, kind of similar to like DNS caches at different levels. The memory cache is often the first cache the browser will examine for resources it can reuse, and it's very ephemeral. It's a short-term cache that only persists for the current session, and likely even less than that. It's fast because resources are stored in RAM. And when there's a cache hit for a resource in the memory cache, it's super fast. But again, you don't have any control over it. It's just an optimization that uses browser's internals and heuristics to figure out whether or not it should keep things in it. Then we have the disk cache, also known as the HTTP cache. This is the cache you control with cache control headers. It's also a persistent cache, and that resources live in it for as long as the cache control header dictates, like max age, so long as resources aren't evicted from the cache before that point. Then we have the Service Worker cache, which is controlled by the Cache Storage API and is layered upon the memory and disk caches. And this is a programmatic cache that is controlled by JavaScript. And that's what makes it so special, unlike the HTTP cache, which is just, it's a key value sort of directive. You know, you can't really program it beyond just putting in a couple of flags like max age, smax age, private, public, things like that. But the cache storage API is very flexible, and that flexibility and programmatic aspect of it is what really gives it incredible capability. The Service Worker cache is the key cog here, if you'll pardon the wording. And the one thing that can make transitions between pages in multi-applications feel really fast, which brings us back to streams again. What can make those transitions fast is the Streams API in JavaScript in combination with the Service Worker cache. And I'll show you how using Workbox, a framework that abstracts the Service Worker API, as well as the performance benefits that come with streaming responses to navigation requests. Before we can stream partial responses from the network and combine them with markup pre-cached in the Service Worker cache, we first need to look at a website's anatomy, much like we do in single-page applications. More specifically, what are the common elements on every page of a website? The whole rigmarole is already so sort of complicated, so we'll want to start with a basic website just to see how the concept kind of works. This is the contact page for my personal website. It's a simple website, but it's mine, and I kind of like it. This website, like many others, has a predictable set of common elements. The header, which in this case also includes a navigation flyout, which consists of a fair bit of markup. the content, and then the footer, which in this case, there isn't a lot of footer there. Of these elements, there's only two things that stay the same from page to page, and those are the header and the footer. The big thing that changes is the content. All of these are what I'll refer to as partials going forward, as they are partial bits of markup that will assemble the final response that the service worker will provide. So this brings us to pre-caching, which in service worker parlance is something we do during the service worker's install event. When we pre-cache stuff, we're telling the service worker, hey, these are some assets that are so critical to the user experience of this website that we should request them and place them in the service worker cache immediately when we install it. That could be any crucial scripts, style sheets, images, literally anything else, or in the case of a streaming service worker that we're about to build, the partial header and footer markup for the page. So let's get started. The first thing we'll need to do is install the Workbox packages we'll actually need. Workbox navigation preload, which enables the navigation preload functionality, something we'll touch on soon. Workbox strategies, which provides simplified caching strategies for use in our service worker. Workbox routing, which registers routes using the caching strategies from Workbox strategies. I'll touch on this. Workbox pre-caching, which handles pre-caching, which we talked about and we'll see soon enough. Workbox, and this is the big one, Workbox streams, which helps us stitch together multiple pieces of partial markup into a single one and uses the readable stream API under the hood to stream it all to the browser. Because these are production dependencies, and there'll be things we deploy to production, we'll want to use the save flag and not the save dev flag. Also, just a quick note, the backslashes here are unnecessary. It's just to make sure that the snippet is readable. Then we'll create a file at the root of our project folders, our project's SRC folder, or whatever your project's source directory is, named swjs or serviceworker.js. I prefer sw.js. To kick things off, we'll import everything we need for the service worker to work. But don't sweat all this stuff. We'll explain it as we go. But here's a quick rundown of what we'll need. We need all of the Workbox navigation preload module. We need to use the following strategies from Workbox strategy. A strategy, to define a strategy in service worker parlance, it just means what is the interaction between the network and the cache, and how should we program the interaction between those two things. So there are three strategies we need, which is the cache first, which means we go from the service worker, we look in the service worker cache first. If that resource doesn't exist, then we fall back to the network strategy. We go to the network, and this is for static assets primarily, like CSS files, things that have hash versioning in their names. The network first, falling back to the cache strategy, which is the opposite of the previous strategy for the content partials. That means the partial content we're getting from the network. And the strategy handler needed for serving and streaming the combined partials, which this is what does the streaming and the stitching together, which we'll get into. We also need the register route method and the route class necessary to establish the route handlers so that Workbox or the service worker knows which strategies to apply to which resources. The match pre-cache method to get the responses from the pre-cache, and the pre-cache and route method, which is used during install to pre-cache assets. And then finally, there is the strategy method, aliased as compose strategies here, and this stitches partials together for streaming markup. Then we need to enable navigation preload. Now, yeah, that thing. The thing I said a little bit ago that I'd get into later. I guess it is later now. So about navigation preload, which you can learn in far more detail in this great article by Jake Archibald than I have time to explain here. So I'll give you the greatest hits. Navigation preload is a way of negating the delay that a service worker can introduce when it boots up. Without navigation preload enabled, this is what can happen on a page controlled by a service worker. The service worker boot up time can cause the navigation request, that is to say, a request for an HTML document, to be delayed. It's not good for your site's loading performance, honestly. Sometimes it's imperceptible, sometimes it's not. Sometimes it can actually significantly delay that that navigation request from even going out. However, with navigation preload enabled, the service worker can boot up while the navigation request is dispatched, ensuring that an active service worker doesn't delay page load. It's a great performance optimization, but it does cause an interesting set of circumstances to occur that you'll have to account for, and I'll call those out as we go through. Now, back to the code. Navigation preload support isn't 100% across browsers. So the nice thing about Workbox's abstraction of this service worker feature is that it will do all the feature detecting work for you regardless of browser support. Kind of nice. Like, you don't have to do all these like, oh, does this thing exist here and what do I do if, that's the great thing about tools. Moving on. One of the things about Workbox that's pretty cool is that you can establish multiple caches with ease. So here we're creating a couple strings for caches we'll define for later. One for assets that are cached during runtime. Runtime caching is you handle caching assets as they come in and as they're requested, as opposed to those that are pre-cached, which are cached way ahead of time during the install event. And two, a cache for content partials. Now on to pre-caching. When the service worker installs, we want to make sure that we pre-cache a few things on top of some static assets. Chief amongst these are 3 items: the partial containing the header markup, which in the case of my website, as you saw before, contains the markup for the header and quite a bit of markup for a settings flyout menu. There's also the partial containing the footer markup. And then a content partial for an offline fallback, which is displayed if the last accessed version of a page isn't available in the service worker cache, which could happen simply because the user hasn't visited a specific page before, because if they haven't, why would it be in the service worker cache? Or a page gets evicted from the cache for any number of reasons due to storage quota or Workbox's own internal logic that can prune things programmatically if they are sufficiently old or any number of heuristics. So Workbox's pre-cache and route method makes pre-caching much easier than if you were to do it yourself. The method accepts an array of items to pre-cache, but each item must be an object containing the URL of the item to pre-cache, as well as the revision hash. As you can see here, there's a placeholder for each of the partials that we're pre-caching for their revision hash. For items that don't have a hash in the file name, think static assets like bundlers, then the revision must be provided manually. In this case, we use a text replacement plugin in a bundler, Webpack in this case, to replace placeholders for the revision string, which we generate at build time. Finally, we have the rest of the assets, which are represented by the self.wb manifest placeholder, which the bundler will replace with the static assets that we want to pre-cache. So in Webpack, you can, with the Workbox Webpack plugin, you can use like a regular expression to say, these are the generated assets that I want to include, or you can exclude things. And then when Webpack builds that out, it will replace that with that whole thing. And it's an array, so I use a spread operator there. But that's sort of secondary to the main idea of this talk. But if you have any questions about it specifically, or really anything, you can find me after the talk, and we can kind of chew on it. All right, now strap in. This is the part that gets kind of complicated, and I hope it's visible. I can't really make it much bigger than that, but I've tried to make all this stuff work. The next part involves the network first falling back to cache strategy to retrieve the content partial from the network that will combine with the pre-cached header and footer partials later on. The way this strategy works is that if the network is available, a content partial will always be fetched from the network and placed into the service worker cache using the cache name for the content partials that we established earlier. But if the user is offline, the last accessed version of the content will be pulled from the cache if it exists. However, what we're trying to do is more complicated than what the network first strategy can do out of the box. We have to account for a few things. So that means we need to create this custom Workbox plugin to handle some of the thorny edge cases around getting this whole streaming thing to work. Workbox plugins are driven by a set of callbacks that fire at different points in the request, response, and caching lifecycle that make up much of a service worker's behavior. In this example, we specify two methods in this custom plugin. The first is, which you can see here, request will fetch, which is fired right before a fetch for the content partial is sent to the network. In that callback, we have access to the original request object. In this callback, we want to check if navigation preload is supported. Now, this is important because when navigation preload is enabled, navigation requests can't be handled by the service worker because remember, they're dispatched as the service worker is booting up. But we can use this additional header, and this header is navigation requests when navigation preload is enabled is sent with this additional service worker navigation preload header that contains a value of true. The presence of this header is pivotal for content partials on my website because it's read on the back end to determine if a route should return a full response for a page containing the header and the footer, which will happen if a service worker isn't installed, or just the content partial that the service worker will return with the pre-cached header and the footer partials that are stored on the client. The reason we need to do this is because the first visit for the page won't have a service worker controlling the page. And you'll want to make sure that your website isn't broken in that case, because without a header, you're probably not including style sheets, and you'll just get this weird, unstyled piece of partial content. But the problem is browsers that don't support navigation preload. In this case, we create a custom X content mode header with a value of partial that we can then send to the server. So even if clients that don't support navigation preload will download a content partial rather than the full page, we still have a hook to make this whole thing work. Now, on my website's PHP backend, I know, PHP, that process looks like this. Look, it's what I learned. You know, you got to start somewhere. I require all the stuff needed to either render a full page or a content partial. And then, excuse me, using a helper function that checks for either the service worker navigation preload header or the custom X content mode header I created, I decide how to send content. I also use the isPartial variable returned from the isPartial helper function and the various functions, utility functions that I use to emit partial markup, because there are some, as I said, weird edge cases that I have to deal with when dealing with partial content in a service worker. That's stuff we'll all kind of go over. Now, the helper function that checks for the request headers is pretty terse. It just checks if the server superglobal array to see if either the pertinent request header is set and that its value is what is expected. How you do this will vary based on your application backend. If you don't have a backend, such as, say, a statically generated website, then your logic will vary. In this case, you'll have to output two versions of each page, one with the full markup and one with just the partial markup. And your service worker logic would have to change too. Rather than using the request, like the navigation preload header or the X content mode header, you would likely just rewrite the request URL to just grab the partial version. And that's something, if you don't want to muck around with headers, you could do that anyway. But this is how I came to it. Now, back to the service worker code. Now that we've finished with the request will fetch handler, we need to add one more handler if there's an error, just to cover our butts a little bit. Remember that I said that this content partial strategy uses the network first falling back to cache pattern, where if the network request fails for some reason, whether you're offline, principally if you're offline, if you're on what we call Li-Fi, we retrieve the last access version of a page from the cache. But this can fail too. Perhaps the user hasn't visited a page at all, or as I said, maybe that content partial was already evicted from the cache. So we need to have that offline fallback that we pre-cached. To do that, we manually query the cache interface to see if it has the current URL. If it does, we're in business. We can just display that, the user will get something, and everything's good. But if it doesn't, we need to check if the response returned from the cache is undefined. And if it is, we grab that offline fallback from the pre-cache and use it instead. And the type of offline fallback you do is really up to you. It can be a simple, oh no, you're offline type page, or it can be more involved. Fun fact, access to the cache interface isn't limited to the service worker scope. You can actually access caches from the window context as well. So on my offline page, I use a script to sift through the content partial cache to find previously cached pages. And then I use JavaScript to populate a list of pages that are available offline so the user has some choices about where they can go until they get back online. Now, I don't have a lot of space in this talk, unfortunately, to cover how to access caches from the window. But if you are interested in learning more about this, I wrote a guide in the Workbox documentation. We recently, by the way, deployed new documentation for Workbox that I worked on last year and we launched earlier this year. Check it out. This is one of those documents. It has a glitch demo embedded that shows you how to do this. Give it a look if that is the kind of thing that interests you. I really like Blade Runner. Now for the fun part. Assembling the partial content with the network with the pre-cached header and footer markup. This is where the Workbox Streams module comes into play. The aliased compose strategies method offered by Workbox takes an array of responses. Each array must return a response and merges them into one response that uses the readable stream interface, which is abstracted by Workbox Streams, the Workbox Streams module, to begin streaming that content to the browser as soon as possible. Now for the piece de resistance, my horrible French accent. Wiring up the route for navigation requests. This one is a terse one-liner. You call the register route method, and in the callback for the method's first argument, you ensure that this route only applies to navigation requests. And the way we do that is through request.mode, which has a number of things. Request.mode can I don't know them all off the top of my head, but one of them is navigate, which applies to navigation requests. And then assign it the navigation handler that we built earlier that has like the custom plugin and all of like the logic around the custom headers, as well as the content strategy handler. And then to top it off, and this one's kind of an aside, but I might as well go through it anyway, we create a new route for just static assets. And this will cover any static assets that were not pre-cached when the bundler generated the service worker. And this just makes sure that future visits will reuse static assets from the cache. And it doesn't have much to do with the talk itself, but again, I'm happy to answer any questions you may have about it if, you know, you're just like, hey, I don't get what you're doing here. Service worker is pretty complicated, so no judgment. Like any questions at all, come and find me. All in all, the finished Workbox-powered service worker is about 75 lines. It's really not a lot of JavaScript, although the bundle for the service worker will probably be about 20K, which for an off-main thread service worker is really like pretty small and has minimal impact on like the responsiveness of your application. And that's far less than if you tried to do this all yourself. And I know how hard that is because I've done it myself and I've done it that way, and it is a mess. It's not that these APIs are badly designed, it's that this is a very complicated thing to do on your own. I highly recommend using Workbox if you just want to, you know, get going with things. So after all of that, you might be wondering, is this even worth it? In my opinion, it is absolutely worth it, especially from the core Web Vitals perspective, or the Web Vitals perspective, which has 5 metrics, whereas core Web Vitals is 3. First, let's look at what the lab data tells us. To obtain that, we turn to our good old pal, web page test. Now, let me be clear. Web page test is a lab tool. It is not always reflective of what actual performance is like for real users in the field. But web page test is an excellent lab tool for testing performance changes from a consistent baseline. These are tools that you use during development. It's perfect for spot checking how, say, a streaming service worker, for example, can impact performance. So in this comparison, we're going to see how performance is affected with and without a streaming service worker using an emulated Moto G4 phone running Chrome on a throttled 3G connection located in Sao Paulo, which now I realize is actually a really kind of relevant thing to Portugal. Now, let me play the first video on the left, which is the homepage of my website with no service worker installed and active. Pay close attention. Waiting. Well, Now, that's not an unusual page load experience, right? And it's not even that slow, all things considered, you know, on a slower connection like that. That's not unacceptable. But now let's see how that looks on the same connection with a streaming service worker. Pretty fast. You'll notice the header appears immediately. And that's the power of streaming partials from the pre-cache and combining them with partial content from the network. You get an immediate first contentful paint and assurance that something is happening. Then, when the content does appear from the network, that streams in and completes the page load. We get instant feedback that something is happening, and it's pretty powerful stuff. Now remember, again, web page test is a lab tool. Lab tools are great for iterative development where you're trying to figure out how changes to your website affect page speed. But in order to see how your actual users are experiencing things in the field, you have to grab field data, or RUM data as it's called. On my website, I collect performance metrics, or rather the 5 web vitals, 3 of which are the core web vitals, using the Web Vitals JS library that is part of the Google Chrome organization. I highly recommend it. It's an especially great and simple tool if you just have a simplified field data collection solution that you rolled yourself. But it's powerful enough that huge enterprise apps can get good field performance insights from it as well. Now, not all web vitals are relevant to the streaming service worker concept. First input delay, or FID, is, in my opinion, weakly tied sometimes to how fast the page loads, although that's debatable now that I think about it. I could be wrong, but it is the first input, and theoretically that could be at any point in the page lifecycle, right? It may typically be as the page loads, but sometimes a user doesn't interact with the page right away. Cumulative layout shift, or CLS, is also not time-based. It's a float-based metric that tracks how much page elements cause layout shifts. It could be relevant. Now that I think of it again, I'm undermining myself on stage. You know, go me. Because when you have like things like fonts that are that are pre-cached, you know, the service worker with or without the streaming concept could have an effect on CLS. In fact, it probably does. So I just lied to you. I'm sorry. But what we want to focus on, though, are the other web vitals: time to first byte, or TTFB, first contentful paint, or FCP, and largest contentful paint, or LCP. Now, before I begin with the stats, I just want to say a bit on the subject of averages. In my capacity as a technical writer and being involved with the core Web Vitals team, we discourage using averages. They seem convenient. I just throw all these numbers together and I just divide by how many they are. And I get a nice tidy number. But they can be skewed by outliers, right? Like say at the long tail of things, you might have like some really poor experiences, or like you have a lot of really fast ones that can really kind of pull that average in either direction. And it's not and most importantly, in my opinion, an average is not really representative of any one actual user experience. It's an amalgamation. Instead, we focus on and strongly encourage the use of percentiles. And our guidance recommends ensuring that your metrics are at the good threshold for any given metric at the 75th percentile. And the 75th percentile is fine, but I like to go a little bit further, and I like to focus on the 90th or sometimes even the 95th percentile. Because if I can improve the 10% or 5% of worst user experiences, I'm definitely improving the experience for every other percentile below it. And now for the stats at the 90th percentile. Without a service worker, my personal website's first contentful paint was about 2.7 seconds at the 90th percentile. That's not a bad LCP at that point in the distribution when you think about it. It's not blazing fast, but it's acceptable on a slow connection that you would see at that point in the distribution. Except with a streaming service worker, first contentful paint is improved by nearly 80%. To 584 milliseconds. And that is a massive improvement in perceived performance. Users with a streaming service worker are seeing content appear much faster than without one. The gains in LCP are more modest compared to FCP, but still significant. Without a service worker, the 90th percentile of collected LCP values was at about 2.8 seconds. However, with a streaming service worker, we shave 28% off of LCP and get about 2 seconds at the 90th percentile. That's not insignificant. And chances are, it should be noted that LCP can vary widely based on screen size. For example, a hero image on a mobile device may not be the largest paint. Maybe it'll be a paragraph or another element that LCP accounts for. Whereas on a larger screen, the opposite might be true. In any event, the streaming service worker gives us enough of an advantage that an LCP, no matter where it is, happens sooner. Because downloading partial markup, as well as the runtime caching of static assets, gives us a decent boost. Now, TTFB is where streaming is really effective. At the 90th percentile without a service worker, we have a TTFB of about 1.85 seconds. It's not the greatest. It's definitely above where we like to be. I think we like to keep our TTFB like below 500 milliseconds, but networks and physics being what they are, we don't always get our way. But it's workable on a slow connection that you'll likely experience at this point in the distribution. However, with a streaming service worker, we reduce TTFB by 90% to 187 milliseconds. That's incredible, but it's not unusual, and it's logical that it is this way. The reason for such a low TTFB is that as far as the browser is concerned, the first byte streaming from the pre-cached header partial count towards TTFB. It's like the service worker itself is like a little mini web server that is just serving this content. And at lower percentiles, it was not uncommon to see extremely low values. In my distribution at the beginning, at like the first, like, I don't know how many it was, but like at the first like 20 to 50 rows were just straight up 0. Like it was instant. Like, and when you use this thing, sometimes it's just like, whoa, like that came up really fast. I love web performance. Now there are challenges to this type of architecture, should you choose to pursue it. And I'd be remiss if I didn't just point at least a few things out. They're not caveats that make this approach unworkable or even unscalable. It's just stuff that you need to be aware of. And in some cases, stuff that you have to be aware of even for single page applications, except maybe some of those tools take care of that for you. Whereas in this case, you kind of have to figure it out on your own. Otherwise, some of the external consistency around what browsers do when they navigate from page to page occur, and for what it's worth, that stuff can be lost, right? And for what it's worth, a lot of the same caveats that single page application architectures have to account for as well. The first thing is understanding what happens with the title element. It might seem a touch weird, but it is a concern with not just the streaming service worker pattern, but with SPAs too. So when a navigation occurs, however you define what a navigation means, you need to change the contents of the title element. But this particular requirement is tricky because when we pre-cache the header partial, which contains the title element, we're reusing that partial for all pages. And not every page in a website has the same content in the title element. But there is a way around this. When we pre-cache the header partial, we leave the title element empty if the header is not used as part of a full response using a conditional on the back end. So what that means is if no service worker is controlling the page, we populate the title as usual. If there is a service worker, we don't populate it because we have to populate it on the client. In the header partial's head element, we use this bit of inline JavaScript. It needs to run in a DOM content loaded event callback because within it, we're selecting an element that isn't part of the DOM yet, so we need to wait for the DOM to be constructed. Once the callback fires, it will read the text contents of a script element in the body and the content partial with a type attribute value of application/JSON and parse it into an object. It then uses the contents of the object's title property to update the title element through document.title. This is a minimal example of what the inline script containing the JSON looks like. There's more data than this for each page for other reasons, in particular the offline fallback that generates that list of pages you can access offline. But this is the basic idea. And that idea is that each page's content partial will have this data on the page so that the script in the head can read its value and update the title element with it. Now for the other weird part of this whole thing. When you're on a slow connection, you get this sort of weird effect that happens where the pre-cached header markup arrives instantly, but the content partial of the network is taking a while to arrive in full. And I had to learn this the hard way because I did this for a client of mine that I've had for a while from Wisconsin. And my wife and I last summer, we went up to Two Harbors, Minnesota, which if you know the geography of Minnesota, I'm from the Twin Cities. The Twin Cities is just kind of south, like toward Iowa, where I'm regrettably from. And then Two Harbors is like kind of remote. It's up by the lake, Lake Superior. And I was sitting in a cafe and I wanted to test this out on a slow connection because internet up there just sucks. And I was noticing that the header was showing up very quickly, but then everything below it was just like nothing's appearing. And I was like, oh, the pre-cache is delivering that content, the header content immediately, but the network is so slow that it's just taking a while for that to populate. So when that happens, this is what you end up with. A header that appears with no content until the network delivers it, if it delivers it. Now, if you're on a slow connection and you return to a website with an active service worker that uses the streaming pattern we just covered, you'd think that maybe the page is broken. Or you'd see the spinner icon in the browser tab and wonder if the server is responding too slowly or at all. Either way, you've got to give the user some indication that the page is loading in the UI of the website. After all, this is something, again, single page applications frequently do. It's not an unusual user experience signal that something's going on. Now, there are a lot of ways that you could do this. Oh, sorry. The simplest uses the CSS empty pseudo selector. For example, say your header partial ends with an open main tag. Well, in this case, an empty pseudo selector would match until the partial content arrives, meaning the content rule here would put in a loading message. And that's probably the easiest method of signaling to the user that something is happening, but there are other ways. For example, you could use set timeout in some inline JavaScript to deliver a loading message if something hasn't arrived within a certain time frame, but in all honesty, I prefer something of a different approach. This method uses the navigator interface's effective connection type property. While this property is only supported in Chrome and browsers derived from it, such as Edge and Opera and others, those browsers do constitute a decent share of users. In this case, it's like 72%. This inline script uses the optional chaining operator to grab the effective connection type from the navigator.connection object. This avoids the sort of errors that you would get when an object property doesn't exist in some browsers, and it avoids breaking stuff. And you don't have to do that stuff like connection in Navigator and like have nested conditionals and all that stuff. Then we check if the affected type isn't 4G, which describes the fastest possible connection type described in the Network Information API. It's a set of enumerated values. So if the value returned is either 2G, 3G, or 3G fast, we add a class of slow to the HTML element. Then in CSS, I've defined an animation that creates a little loading spinner. Now I did this because I didn't want to load an extra image, but I'm not going to get into the entirety of the CSS itself, since it's kind of up to you how you want to do this. But the idea is that I have this bit of HTML with some markup that has a series of sort of pulsating dots, right? And it looks like any number of spinners or loading icons that you might see. Here, I take care to make sure that the spinner is reasonably accessible. So I give it an ARIA label with a content of loading page, and I remove the elements that represent the dots from the accessibility tree with the ARIA hidden elements, or ARIA hidden attributes. And then with CSS, we can conditionally render the container for the loading animation if the effective connection type is slow or slow-ish. And the result on slow connections is this. It's nothing fancy, but it gets the point across that something, anything, is happening, and it helps to avert the assumption that the experience is broken on a slow connection. Now, it may not have the widest browser support, So it's a good fallback to see if the network information API is supported. If not, the method with the empty CSS pseudo class could be a potential fallback if you wanted to go that way too. And I didn't make slides for this, but I kind of just thought of this because I ran into this problem. A lot of people use a CDN or like Cloudflare, right? And one of the important things that you have to do is you have to account for the vary response header. And what the vary header does is it instructs the cache, both your disk cache and any proxies or public caches like CDNs, how to key cacheable responses to specific headers. And this is important because I found out that if I wasn't keying against the service worker navigation preload header or the X content mode header, I was having this weird double header thing that was happening. It was a weird interaction between the service worker and the CDN where it was storing older versions of the content that I had had before I had even deployed a service worker and was creating all these problems. And once I applied that vary header, I purged my cache and everything was fine. But believe you me, I was sitting like there for probably about a good couple hours, like wondering why the hell everything was broken and like I'm the worst developer in the world and why am I even doing this? You know, what some of us do every day. So anyway, there you have it. A navigation scheme for multi-page applications, or websites, as I like to call them, that deliver on faster navigations by progressively enhancing the browser's default navigation scheme without replacing it. Now, if you're interested in further material on this subject, I have some recommendations for you. The first is this fantastic article by Phil Walton, which is the first instance in which I discovered it. Phil's analysis has an almost dogged focus on field data, which really proves just how beneficial that the pattern can be. The second is Jeff Posnick's take on the pattern. And Jeff Posnick is the principal engineer for Workbox, which is an impressively deep dive into some of the architectural aspects and concerns. It gets into stuff like Firebase and like Express. Like it's just a really comprehensive, great take. And if service worker is your thing, it's a safe bet that anything Jeff writes on the subject is worth reading. And it also has a video version of the article, which is Jeff's talk from Google I/O some years back, in case you just prefer videos. And the last one is an article I wrote for A List Apart about over a year ago, which, if you're interested, shows what it takes to achieve this pattern without the need for Workbox. Spoiler alert, while it works, it is a ton of effort. It requires direct knowledge of the readable stream API and the service worker API and the cache storage interface. And unless you're just deeply and exceptionally curious about what all this looks like without an abstraction, Workbox is probably a better bet. Now, without Workbox, you can send really teeny tiny service workers, but again, Workbox works off of the main thread, and that's not really the time where I care too much about how much JavaScript is being sent, as long as it's not an obscene amount of it. And like, it's not. Workbox is a really lean abstraction. Whew. Okay. And with that, thank you for your time, curiosity, and your love for all the things web. I don't have my slides uploaded yet. I was kind of toying around with slides until the last minute. But I will have them up today, and I will update in the Slack channel. I think each room has its own Slack channel. I will find the right room and I will update it. This is room 6. Cheers and thank you. Looks like we got, sorry, you can leave if you just want to get going, like if you're hungry or whatever, but I do have some time left, and if anybody has questions, I'm happy to take them on. You can just raise your hand, but if everyone's like, no, screw that, I want to eat, like, do what you do. Going once, going twice. You got one?